And let's look at a secant line on the sine function, right? So we've already talked about how to graph a sine function, right? So a secant line on the sine function. Most likely I'll change it to cosine for the test. But we want to be able to graph a nice version of the sine function. Really in quadrant 1, 2, 3, 4, right? So I need quarter steps. What are my quarter steps?
Pi over 2.
Pi over 2. So
Yes.
every 90 degrees, every quadrant, right? So a 1 pi over 2, a 2 pi over 2. I typically don't reduce my quarter steps, even though they will. Like the 2 pi over 2 is really pi, right? But I don't reduce them. And so there's my period of the sine function, right? You should be able to see it right away. How high does the sine function get? How low does it get?
1 and negative 1.
Yes. Why is that?
Math.
Sine of theta is bound between 1 and negative 1. Why is that?
So sine is just the ratio between the relationship of angles. So
Sides. Yeah,
sides.
yeah.
And so it can't be more than 1.
Why? I agree. Why?
Because math.
Okay.
That's
Yeah.
that's what I've got.
Yeah.
That's all I've got.
Right. It's close. It's simpler than math.
I always say just because, yes.
Just because, yes. The reason why you should not smoke pot is because your parents told you. No, the reason why you shouldn't smoke pot is because it's still illegal some places, and it could screw you up. So, but
and
why?
it's expensive.
Oh, sure, lots of yeah. So, but why is sine bound between negative 1 and 1? Sine is the ratio of the opposite side over the hypotenuse. What do you know about the hypotenuse of a right triangle?
Is the longest side.
The longest side.
The triangle.
Exactly. So, can my ratio ever be bigger than 1? No, it would mean the opposite side would have to be bigger. And so we know when my angle is 90 degrees, the height and the hypotenuse are the same. So when I divide that, even though it's not a triangle anymore, but it's a thought, right? If I go to 90 degrees, there's no triangle anymore, but if there were, the height and the hypotenuse are the same. So sine of pi over 2 is 1, right? So then we have our little pattern here, 0, 1, 0, negative 1, 0. In fact, I can work that backward, right? But here's my main sine function, and I want to think about that curve, right? In quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? All students take calculus, right? You see my little separation here? There's quadrant 1, quadrant 2, quadrant 3, quadrant 4. All trigs are positive, so sine is positive, so sine is above ground. Sine is positive, so sine is above ground. Only tangent is positive, so sine is negative, so the sine curve is underground, negative. Only cosine is positive, so sine is negative, so sine is underground. The curve is underground there, right? How are we doing here?
Pretty good. Could you just explain like the inequality of sine you have up there? And
yes. So I'm saying when we had done the properties of the sine function, we said that the domain was all reals, right?
Mhm.
And then we said that the range was -1 to 1 inclusive, right?
Right. Mhm.
One thing I left out is sine is odd, right? Sine is odd, right? Do we agree from the curve?
Oh yeah, it could.
So,
The origin.
right.
It's
So sine of theta equals negative sine of negative theta. That's what it means to be odd, right? F of x is equal to the opposite of f of negative x. That's my definition of odd from test 1. So back to your question about this inequality, which came from my range, right? Which is obviously
right.
clear on the curve. You can see that sine goes at most to 1 and goes all the way down to -1. And again,
Yep.
it's about that ratio of opposite side to hypotenuse, right? Hypotenuse is the denominator, so that ratio can never be bigger than 1 because the hypotenuse is always the biggest side.
Okay. Right. Okay. All right, I get it now.
Yep.
But why is it like inclusive? Will it?
So when I'm building my sine curve, right? I'm talking about the heights of the unit circle, right? So height of the unit circle, there, 0. Height here, height here, height here. You can see my height is building up, and when I get to pi over 2, the height is obviously the biggest it can be, and it's a unit circle, so it's the radius, so it's 1.
It's 1. Okay.
Yeah.
All right, I get it now.
Yep. Nice. And remember
Thank
our
you.
point. We're always talking about a point on the circle, right? And the with radius, right? And down to a perpendicular, we always are talking about the radius being connected to a point on the circle, right? And then that's how we create our triangle, which is where this sine, cosine, and tangent all come from.
Yep. Okay, thank you, Professor.
Yep. Nice. So I want to look at a slope of a secant line on this sine curve. And what I'm going to do is I'm going to pick the point 0, right? And maybe some other point like 5 pi over 6. So I've got 2 points there that I'm going to connect. And I'm going to create that secant slope, or even the secant line. Let's do the whole secant line, right? And this is a pretty typical problem in Calc 1. So it's good for us to be able to do it now, because if we could do it now, we'll impress the hell out of our Calc 1 teachers. Let me see how many students I have in my Calc 1 class already. So, I got 2 students in my discrete structure class. That's computer science class. 1 student in my face-to-face education class, 6 students in my online education class, and 1 student in my Calc 1 class. And it's none of you, and I'm not offended. I'm preparing you to take Calc 1 with the most demanding, most difficult teacher you've ever had in your life. That's what I'm doing. Okay? Diego, what are you going to say?
Just wait after this day passes or this week passes. I mean, registration just opened.
Don't wait. Don't wait. You will miss out on what you want, what fits your life perfectly. Plan it out today. Get in your classes today. Make your payments. If you miss a payment, you get dropped from the course and then you go on the waiting list. It could screw everything up. Okay? Alan, what were you going to say?
I thought there's still online classes
next semester?
There will always be online classes. There actually are still remote classes. So a difference between an online class and a remote class is online. There's no video lectures. You got to read the book. You got to read the book. You got to it's demanding. And then the remote would be just like this. Someone teaching you through Zoom or through Blackboard, whatever the Blackboard app is. Yeah.
Hey, Mr. Moore, I have a question.
Yes, Robert is fine, Rafat. Thank you.
All right. So, like, your class in particular, you going to be in person?
Yes, face to face on campus. Most likely, I'll be in a clear plastic bag.
Yeah, that's too
But I'll look just like this, but a little foggy.
We'll be in Tacoma Park as well, right?
Tacoma Park is where I teach. Yes. Grace.
I was going to ask if you're in Tacoma Park or Rockville, but you answered my
Yes,
question.
Tacoma Park. That's where I was hired. I've been there for 5 years now. Before that, I was in Dundalk, another very small school for Community College of Baltimore County. And before that, I was at Brookdale. That's where I graduated from in New Jersey. That's a little bit bigger than Tacoma Park and Dundalk. I like the smaller schools. I guess that's what I guess I keep getting hired at smaller schools, but so I want to come up with this secant line, the secant slope, right? And I need a slope first, right? Sorry. So let me redraw my picture here a little bit. I said 5 pi over 6, right? So I said 0 and 5 pi over 6. And so obviously it helps me to have 2 points, right? So 0 comma sine of 0 and 5 pi over 6 sine of 5 pi over 6. It should be pretty obvious that sine at 5 pi over 6 is positive because the curve is above ground. But I still want that same process, right? So I have an x1, y1 of 0 sine of 0. Can I simplify that at all? What is sine of 0? So my chart.
0?
Yep. And I have an x2, y2 of 5 pi over 6 sine of 5 pi over 6. I already know that that is 5 pi over 6 plus sine of pi over 6, right? Because it's still a positive. Remember, quadrant 2, right? In quadrant 2, sine is positive, right? All students take calculus, right? All students take calculus. So sine is still positive. So I just need a reference angle. And what is sine of pi over 6?
One half.
Nice.
Pi over 6.
One half. Yep. Everybody following me? Now I need the slope of the secant line, which is f of x plus h minus f of x over x plus h. I'm sorry, over x plus h minus x, right? Sine of the arguments, difference of sine of the arguments over the difference of the arguments, right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1, right? So what is that? That's sine of x plus h minus sine of x all over h, right? You with me here?
So far, so good.
Anybody confused? Anybody? I got my chat open, so if you want to talk to me without.
No, I'm gonna be like upfront. So you said you get 0 is less than or equal to this. Just to review a little, 0 is less than or equal to sine of theta, which is less than or equal to 0. I thought like Where'd you get that from?
Oh, no. We had said -1 is less than or equal.
Yeah, 1 -1.
Yeah. Where do we get that from? That's from the ratios, right? So we're thinking. Remember, we're talking about the height of a. It's easiest if I think of this as a unit circle. Okay, so my radius is always equal to 1. So the sine of theta is coming from the height of that triangle, right? And so, so think about that. What's the maximum height of that triangle? Even though it's not a triangle anymore. And this is a beautiful thought for calculus, because we talk about this stuff in calculus all the time. Even though if I go all the way to 90 degrees, I don't have a triangle. Can you imagine what that ratio would be? Can you imagine what the height would be of that triangle, even though that triangle doesn't exist, right? And this is a great thought about life, also. And
And just to be clear, it's 1. Right?
1, exactly. And this is called a limit, right? This is a limit. This is something you do first thing in calculus. And we're doing it here. I'm just not making it formal. I'm not saying we're doing limits. Okay. So anyway. Rafah, yes, you with me now? Malcolm, go ahead.
I'm not clear how you avoid 5 from this pi.
One more time, Malcolm. I'm sorry, I couldn't understand it.
Yeah, I'm not clear how you avoid or omit 5 from this sine 5. It was.
Yeah. So sine of 5 pi over 6, we had just done a bunch of those, right? So cut pi into 6, right? And then 1 pi over 6, 2, 3, 4, 5 pi over 6. So there's 5 pi over 6. So this triangle here in green has the same height as this triangle here in black. And because they're both above ground, they're both positive. And because pi over 6 is my reference angle, I can refer to my table there. So I don't have to think about 5 pi over 6. I know it's the same height as the one at pi over 6.
Okay. So sine 5 pi over 6 and sine pi over 6 have the same height.
Correct.
Okay, thank you.
Yes, you got it. Now I know something else, right? I'm getting my secant when x is 0 and h is 5 pi over 6. Right? I'm getting my 0, right? I'm getting my slope when x is 0 and my distance h away is 5 pi over 6. So I can simplify this really as sine of 0 plus 5 pi over 6 minus sine of 0 all over 5 pi over 6. Everybody with me?
Yes.
Good, so I get sine of 5 pi over 6 minus 0 over 5 pi over 6. Right, I'm just simplifying. And I already know that sine of 5 pi over 6 is sine of pi over 6. Oops, sorry. All divided by 5 pi over 6. And so I get 1/2 divided by 5 pi over 6. Which is what? 1/2 times 6 over 5 pi. So 3 over 5 pi. Sorry, 3 over 5 pi, yes. And there's the slope of my secant line.
Professor, I have a question.
Yes.
So the last
Grace.
few homework questions for chapter 6 were asking for the average rate of change. Is this like the same thing?
Exactly. Secant slope. Average rate of change is secant slope. Let's just make sure we get the same slope from our 2 points, right? Remember, when I ask you for a secant line, I want you using your difference quotient as to get your slope. But then you can double check it using, whatever you did in 8th grade. So look at our delta y over delta x here. It's 1/2 minus 0 over 5 pi over 6 minus 0. And of course, that's the same answer, right? Right, you with me? I use those 2 points to calculate my slope. Of course, I got the same answer. So I created a little bit of something on Desmos. I was hoping that some of you are going to attempt that piece where, so my curve is the sine of x. Where's my mouse? There it is. And then I have the point A comma sine of A, so you can see that point is there. And then I have the next point A plus H comma sine of A plus H. That's there. So you can see I can calculate, I can get the secant slope, or at least the secant line from here, right? So there's my secant line. And there's my equation, y minus sine of A equals, here's my secant slope. Do you see my secant slope here? Sine of A plus H minus sine of A over H. Now this is a lot easier for me because I know sine of A is that sine of x, I had sine of 0, right? So y minus sine of 0, which is 1, so y minus 0 equals, what did I get for my slope? I got sine of A over, sine of H over H, right? Sine of H divided by H, that was my secant slope, and then x minus A. And you see it's the same line, right? So again, I'm using, right? What did I get for my secant slope? I got sine of H over H. Right here you can see it. Sine of H over H. This is a very important function in Calc 1. Sine of x over x, right? How we doing? We okay? I have a feeling I've lost several of you, but
I mean, it's a lot, but I think I sort of understand it.
Like, I know what you're doing, I understand, but at the same time, it's like, yes.
yes, I appreciate the honesty there. I know it's a lot. I know it's tough. You don't have to get everything the moment I say it, okay? You don't have to get everything I say the moment I say it. I often walked out of class going, what the? And that's fine. There's nothing wrong with that. You need to process. You need to read. You need to research. You need to practice. Are we okay with this box? Is everyone okay with this blue box here that I've got? That my secant slope on a sine function is sine of H over H.
Yes.
Okay. And that's including the point 0, right? Go ahead.
No, I just wanted to ask, so would fx always be sine 0?
Yeah, so in this particular case, and the problem I would give you, yes. Because I'm really interested in when A is 0. Okay, so I've got my A set to 0. And I'm going to let H get just a little bit smaller, right? I'm going to let H get a little bit smaller. In fact, a little bit smaller. In fact, a little bit smaller. And I want H to go to 0, all right? Because now what do I have? What's my slope? Sine of 0 over 0. As H goes to 0, I now have sine of 0 over 0. What is sine of 0? 0. So now I have a 0 over 0. But look at the slope of this thing. Look at this blue line. Is that a slope that seems normal to you? Can you tell me what that slope is? If you look at the grid, you can see it pretty quick.
Y equals X.
Yes, it's 1. The slope is 1. So even though my slope is a 0 over 0, my calculation of 0 over 0 is 1. Okay, this is an essential problem of calculus. How do you divide by 0? What happens when you divide by 0? Especially what happens when you have 0 over 0. Go ahead, Anil.
Okay, so yeah, I was gonna ask, how is the slope 1 when you're dividing by 0?
Isn't that beautiful? It's
Or
a
is that
beautiful
gonna
thing.
be like
It's a
for
beautiful,
another
yeah,
day?
exactly. It's a pretty tough. How does God exist? I mean, these are great. These are the essential problems of our lifetime, of the universe, right? How do you calculate a slope with 1 point,
Yep.
right? And so it's the same idea of can you get somewhere without ever getting there? Can I predict what the slope is going to be when h goes to 0? Even we already know h can't go to 0. I can't have 0 over 0. We already know this. But if I could get really close, what is the answer? Same thing.
Oh,
If I
okay.
can get really close to the end of life, right? Can I
Right, so-
can I see the purpose of it all?
sort of like a limit. Or-
It is a limit. It is exactly what it is. It's called a limit.
Okay.
This is the first thing you talk about in Calc 1. We've been doing them in this class. We've been doing them in this class quite a bit. We don't make it formal. We don't talk about that we're doing limits. We don't talk about the sum of a series as a limit, but it is, right? If I could add everything up, what would you get to, right? If I could calculate a slope with 1 point, what would I get? That was our secant to tangent problem, right? Alejandra, and that is with the homework with the average rate of change. Is that correct? What you're asking me there? Yeah. Yes. Exactly. So we agree with this blue box now. That if I'm talking about my fixed point at 0, 0, right? So there's my fixed point, and there's some other point, and this distance here is h. Then we get the slope of that secant is sine of h over h. Yes, we're okay there.
Yeah.
Yeah.
Nice. All right. I don't have much time left, but I want to start our last section of chapter 6, and I won't finish it, so I'll finish it on Wednesday. And that is, we're looking at, so this is 6.6, graphing y equals plus or minus a times sine of b times x minus c, all plus d. And I'm using all capital letters. It doesn't matter. Lowercase letters is fine. But I put them alphabetically because that's where I want you to focus. I want you to focus on the A first, which is called the amplitude. I think it's easier to imagine it as the radius of the circle. B is called the frequency. I like to think of that as the speed of the point moving around the circle. C is my phase shift. Which is really just my horizontal shift, right? Left or right, inverse, right? And then D is called the midline, which is, of course, my vertical shift. Midline. this is a very, very complicated process. And so you have to be really, really organized. So I'm going to try and give you very clear steps on what to do. Okay. But we want to picture, right, the original sine function, I'll call it the mother, inside of this red box, right? And of course we know 0 to 1 to 0 to -1 to, right? We know that the picture of the sine function, right? So this is y equals sine of x. But I'm really trying to picture the dimensions of this box. And I'm going to get the dimensions of the box from these guys. Okay? So first of all, I know my range is from -1 to 1, and I know my period, my domain, is from 0 to 2 pi, right? So I can already see that my height of my rectangle is 2, and the width of my rectangle is 2 pi, right? So our height of our rectangle is 2a. It's the radius up and the radius down, and so we're adding them in absolute value, right? I need double the radius for my box, right? I need the whole diameter for the box. I know that the width is simply the period, right? And then of course my quarter steps I want to mark as well, right? I want to see those quarter steps marked. How are we doing here? Are we okay? Nice. So I've got to figure out all of this, and then I simply move. Oh, and by the way, this is the midline, right? And this is my start, or my horizontal shift. So I guess I want that to be my start, right? The phase shift is where I'm starting this rectangle at. So I'm going to find the height of the box, double my radius. I'm going to find the width of my box, the period. I'm going to find the start of the box. I'm going to find the quarter steps, and then I'm going to find the midline to shift up and down. So I want to I guess I need a little bit of a clearer step-by-step, right? And I'm not going to get it done today, so just be okay with it, okay? Graph the mother function. Y equals sine of x, right? Graph the reflection, if any. So y equals plus or minus sine of x, right? So the first graph, 1, 2, 3, 4, right? I mean, this is how quick I want you to be able to do it in my Calc 1 class. There's my sine function, right? So there's y equals sine of x. If I had a negative out front, I'd be asking you to graph the reflection. And what does that do? It takes all of the positive y's and makes them negative. So I'm going to just move everything. I'm going to reflect around the x-axis, right? So there's my negative sine of x. Is everybody okay here?
Yep. Yeah, you
nice.
Just switch.
Yep. Yeah, all positive y's become negative y's, right? And remember, you can see that negative is outside of the function, so it's behaving on the y's. If it was inside the function, it's behaving on the x's, right? It's affecting the y values because it's outside. Find the amplitude. graph y equals a sine of x, right? So it's easier for me to start with an example here so that as I do step by step, you can see what I'm asking you to do, right? And so I'm asking you to draw the mother, the daughter, the granddaughter, right? The great-granddaughter, etc. As I change anything or figure out things, I want to keep adjusting my graph as I go so that I don't do the whole thing at once. And of course, I'm going to check everything on the calculator. As I do something, I'm going to check every single step on the calculator. So let me give you my version. Y equals 2 sine of 2 times x minus pi over 3 all plus 1. So it's the worst possible. This is as bad as they get. And I think I usually will keep the midline out, right? I will usually just have the midline be 0, so it's always at the x-axis. The middle of the rectangle is at the x-axis, right? And remember, my idea is I want this to be plus a minus a, so a height of 2a, right? This is my midline. These are my quarter steps, right? This is my start. These guys are all my quarter steps, right? 1, 2, 3, 4 quarters, right? This is my midline. And this distance is the period, right? Which is going to be 2 pi over b. So that's going to give me my whole rectangle. And then I'm just going to just see my, right, here, 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 here. I missed a little bit, right? And there's my, so I'm going to create this rectangle with my process and then move it and then draw the same old sine curve I know how to draw, which is this one, right? Quarter steps, max height, min height. Very, very simple. Very complicated. I mean, my headache is pounding right now, right? But this is my process. I'm not going to finish this today. You're not going to stress about it. You're not going to be panicked about finishing homework 6, okay? You hear me? Chapter 6 homework. I put it all in one. The last few questions are related to this. And Alejandra had already asked me, what the hell is this? I'm still not going to be done with it, Alejandra, so you got to wait for Wednesday, okay? All right, let me get a nice clean page here and start over. Y equals 2 sine. Y equals 2 times the sine of 2 times x minus pi over 3, all plus 1. So already we can see our amplitude is 2, right? So I've got my sine function in this black box, right? With my quarter steps, yes? Oops, did I miss it? No, I got it. 1, 2, 3, 4. So my sine function is here. Please, somebody let me know that I'm not losing everybody. Y equals sine of x, yes?
Yeah.
Oh yeah.
My amplitude, it's not a radius of 1 anymore. It's louder, if you will. The amplitude is 2, which means the radius is 2. Okay? So the new box that I have is going out to here, and I am drawing that sine function. And I believe you did this in your 098 course, where you changed the amplitude, which is changing the radius, which is changing the height, the stretched out piece. And have you heard of AM, FM radio? Amplitude modulation will take that radio wave and extend it out higher. So your Your radio, when you're tuning it, is searching for that wave at that height. Frequency modulation, FM radio, is changing the speed of the rate of the wave. So everything is at the same height, but the frequency is changed. FM, frequency modulation. How are we doing here?
Doing good.
Nice.
But what does
Pretty good.
what does the oh wait, do you just move to the right pi over 3?
Exactly. That's my phase shift. That's where I'm going to start.
Okay.
Yes. So before that, I want the period, right? So my period is going to come from whenever I have a sine function or a cosine function, 2 pi, which is the period of the original mother, over b. So period is going to be 2 pi over b. Okay, for us, that is 2 pi over 2, so pi is the period. Now remember look at that 2 inside here. Let me highlight it in green. Let me highlight it in blue. I'm multiplying by 2 inside, correct? Inside of the function. Yes, everybody with me? Multiplying by 2 inside of the function. Multiplying inside is actually dividing because x's behave inversely. So instead of it stretching out the period, it's compressing it, right? So now my period is pi. So look at the curve now, y equals sine of 2x. Oh, and I had a 2 out front, right? So look at my original curve, 1, 2, 3, 4 quarter steps. Here's my original curve. Here's my amplitude modulation. I went up to 2. Look at my new box, right? Again, I'm seeing those quarter steps, right? There's my amplitude modulation. And now my frequency modulation. I'm changing the period to pi. So I'm going to end at pi. And I still need quarter steps. I have to figure those out still. But there are my quarter steps. So here to here to here to here to here. There's y equals 2 sine 2x. I've changed my period. I still split it into quarter steps. Right? And you can see the frequency. Now, if I finish this red curve, right? If I finish this red curve, so you see the sine function there, right? And it would repeat again, right? So you can see the frequency is doubled. It happened twice. The sine curve is a point moving around a circle. Sine of 2x is a point moving around twice as fast. So it happens. So it draws the curve twice. Again, we're doing all of this on our calculator as we go, right? And I'm at a time, so I'm going to finish it Wednesday. You can do almost all of homework 6, except for this phase shift piece, which I haven't finished, right?
Okay, thank you, Professor.
All right, sorry for the headache, everybody.
Have a good one.
It's fine. Thank you, Professor. Have a good one.
Yes, Professor.
Thank you, Professor.